Hello guys, welcome to our channel. Now we are going to see the topic 1 in linear algebra, which is linear combination of vectors. Before going into this topic, if you guys didn't see in my previous video, which is the basic terms in linear algebra, I'll kept it in the description. Please go and see the video and come into this. Then only you can understand each and everything in the linear algebra subject clearly. Because basic terms is what mostly everyone avoid it. If we know that, we can always and easy to go into the another topics. So let's get into the topic. Here, linear combination of vectors is what I have given first an example. As you guys know, 3 is a scalar and 2, 3, 4 inside the bracket is vector. So how it looks like scalar times vector plus 2 which is scalar and 1, 2, 3 is the vector. This also look like scalar times vector. Everything this I have discussed in the previous video. Please do see that and come after this for better clarity. And if we multiple it and add that number, add that vectors, then we'll get one answer. That is what the linear combination of vectors. Linear combination means combining both the vectors. So in the red pen I have noted it. First see here clearly 3 and 2, 3, 4 is like scalar multiplication, like scalar times vector, and 2, 1, 2, 3 is scalar times vector. If we multiply it, we'll get one answer, and if we add that, that is what the vector addition. The vector addition also we have discussed in the previous video itself. So this is what the linear combination of vectors means. Then we'll go on to the linear dependent vector. Linear dependent vector is, it is a set of vectors, not a particular vector. Set of vectors means like one vector, here it should need to occupy one vector and comma another vector, comma another vector. This 3 all is a set of vectors. It won't be like a particular vector. If anything in GATE PYQs you can check, or in the GATE exam, everything they'll give in a set of vectors for finding the linearly dependent vectors, and also for the linear independent vector also they'll give it as it is like a set of vectors. So let's go to the next point. It depends on another vector. As you guys can see here, linearly dependent vector, the word dependent vectors are dependent. That's what the meaning of this linear dependent vector also depends on another vector. Another vector means how I am telling the set of vectors. So here see the example. This is one vector, this is another vector. How we are telling that this is linearly dependent? See here, 2 times of this vector gives this answer. So definitely it is a linearly dependent vector. This depends on this, like it is linearly dependent because 2, 1, 2 is equal to 2, 4, like what I have said before. It is for 2 vectors. This is example for the 2 vectors. I hope you understand this. Let's go to the next example. See here, it is for 3 set of vectors. U, we are going to take it as U, V, W. For 2 vector, we can directly tell, like if we multiple with any other, we can get that. So 2 vector is what easy. For 3 vector, it is totally different. See down, U plus V is equal to W. Then it is linearly dependent. How I am telling means, check it is linear dependent or independent. It is definitely linearly dependent. How I am telling is, if we add this, the W will come. In linear dependent, if there are 3 vectors or 2 vectors, it doesn't matter. at least any one vector need to be dependent on another vector. That is what linear dependent. In the introduction itself, I have written that only. So this is what the main. Every students get confused of this. For three vectors, and that thing was dependent, and they'll write it as linearly independent, and marks are gone. So don't make that mistake. Okay, let's go on. See here, how I am telling is u plus v is equal to w. It is linearly dependent. Just add this. 1 plus 2, 3. 2 plus 4, 6. 3 plus 7, 10. Then absolutely it is a linearly dependent. If the thing this is not works means just subtract it, like w minus v, then u will come. Then also it is linearly dependent. Like see here, we can also write it as w minus v is u, w minus u is equal to v. So mathematics is like a very interesting subject. It doesn't have only one method, it have many more methods, and if we go deep into it, we'll dive into different solutions, different methods, different ideas. We can explore different topics in that. So stay tuned always, and don't forget to hydrate yourself. Hydrate, eat healthy, and continue the next. I hope you all doing well. So let's go into the another point in the linear dependent. I'll tell it. In linear dependent, we need to express at least any one of the vector that depends to another, even if it is by multiple with scalar or vector addition like u plus v. Yeah, that only I have said before. It should need to depend on any one of the vector. Like for two vectors, I have told it depends, or for three vectors, it need to satisfy the expression that I have given there, u plus v is equal to w. Again, another example, 1, 2, 3, 2, 4, 7, 3, 6, 9. Let's take it as UVW as before. But here we have done 10 in the previous example, but here 9. We can't able to tell it as u plus v is equal to w because 7 plus 3 is 10. How the 9 won't come? So it doesn't mean like it is not a linearly dependent vector. We need to check in another ways. As I have said before, mathematics is very beautiful subject. We have different topics. So we need to think differently. If one method doesn't work, we shouldn't need to write. It is not like the solution is not came like that. We shouldn't need to write. We need see here, u plus v is equal to w is not come, but it depends on another way. That what I have told before. Don't just see in only u plus v is equal to w method. Okay, so it have another method and it is linearly dependent. How? See here. See in the question itself. If we do scalar times vector, which is multiple scalar in this vector, and we'll get this w. What I have told before, at least any one vector depends, then it is definitely linearly dependent. So see, it is linearly dependent. If we multiple scalar multiplication done here, then we'll get the w. Like see here, this is the correct way of we need to write. Like this is the way that I have written in this form. Like w minus w is equal to 3 into u plus 0 into v. Then we'll get this answer. So then absolutely it is linearly dependent. And another note, coefficient could be 0 or non-zero. Coefficient means this 3 and 0 only coefficients. It can be 0 or non-zero number. So it is our way, our wish to write it. I hope you understand this well. If you have any doubts, kindly comment below and I'll definitely answer each and every comments and also answer your questions. Let's see another example. Okay, let me wind up this session. If you have any doubt, kindly ask the question in the comments and I'll answer you. If you enjoyed this video, just click the like button and share it with your friends, and please do subscribe to our channel so that we can make more upcoming videos like this related GATE syllabus notes. Thank you all for joining with us. Bye, and I'll see you in the next video.